We have today a lesson on electrochemical series of metals. We are introduced to this lesson partly because when I did oxidation and reduction with you, I told you about the ease with which metal loses an electron. You know, oxidation, do you know, is a process of electron loss, right? It's a process of electron loss. So it's connected with oxidation, you can see. You know, sodium, for example, Na, it loses an electron and becomes Na plus. You see this? Sodium loses an electron and becomes Na plus. It can do this very easily compared to other elements, say zinc. Compared to the element zinc, sodium can lose an electron and become sodium ion very easily. And so too we can say zinc. Take zinc. Zinc can lose an electron, two electrons, much easier than silver or mercury. So the ease with which an atom of an element loses an electron, or sometimes two electrons, sometimes three. In the case of platinum, is 4. In this way, the ease with which an atom of an element loses electrons and forms ions. Based on this, we have prepared a series known as the activity series. This is called the chemical series, electrochemical series of metals. It's a part of electrochemistry, a branch of chemistry. Electrochemistry. You can see now, potassium can lose an electron and become a potassium ion easier than any other element. Potassium is right on top of this. Now, do not get confused with the chemical activity series, something different. It's also there. But this is electrochemical series. In this electrochemical, you will find some elements are not there, and some elements have found out place earlier also. Electrochemical elements are. So in this series, ions or atoms will show tendency to lose electrons. Atom will show tendency to lose electrons and form ions. They come here. They are written in the form of a vertical series. Where the most reactive one comes on top and the least reactive one comes at the bottom. This series is called electrochemical series of metals. Electrochemical series of metals. I repeat, the ease with which an atom loses an electron and forms an ion. This is the basis of electrochemical series. Now, metals can be arranged in a vertical column in such a way that the metal which loses electron most easily comes on top, and the metal that loses electron least easily comes at the bottom. You know, platinum is a very costly metal. Gold, very costly metal. You know. Silver is also very costly nowadays. So you can see gold, you have platinum, silver, even mercury. These are all costly metals. The reason is they are not willing to part with anything. They keep everything to themselves. They would not like to part with an electron. They would like to keep it. You see? They are very poor reducing agents. Whereas the top ones are all excellent reducing agents. These are all excellent reducing agents. Whereas platinum, gold, silver, these refuse to part with their electrons. That's why they are so costly. Unless they are willing to part with their electrons, they will not change into a compound. Unless these metals can part with the electron, it cannot form a compound. And that's what you want. Gold should not form a compound. Gold should remain gold and shining, lustrous. Isn't it? That's why gold is so costly. It refuses to combine with anything else. With great difficulty, we can get auric chloride. But the point is, normally it doesn't combine either with the oxygen or the air. It doesn't combine. Platinum also is like that. Silver, it may slightly may combine a little bit. Then you move upwards, mercury, copper vessels will be having greenish tints inside it after some time because the combination with carbon dioxide and oxygen in the atmosphere and moisture in the atmosphere. All these other metals are willing to part with electrons. So now, if you prepare a list of ions on this line, potassium ion first and platinum ion last, we have got a vertical series. This is the electrochemical series of metallic ions. And this is the electrochemical series of first one, metallic atoms. So atoms changing into ions, chemical reactions start. This is going to get. So you can easily see one thing from this. The metals up to lead, potassium to lead, all these can displace hydrogen from acids. Hydrogen also is found a place in between. Can you see that? A non-metal hydrogen has also found a place in between here. After lead, before copper. This shows hydrogen also is not willing to part with its solitary electron. It is not willing to part and change into its plus. So that is why it is included here. We say these metals are all they are talking about a name. In the periodic classification, when we learned, I told you these metals are all they have a electropositive nature. They are all electropositive. All metals are electropositive. Hydrogen is also electropositive, luckily. That is why it has been included in this list. Hydrogen is also electropositive, and so it finds a place in this list of electrochemical series. A series of metals. In that, it has found a place as a metal here. Hydrogen is not a metal, it is a non-metal. But it can form hydrogen ion. Easier than copper, mercury, silver, gold, or platinum, which are considered to be metals. Then why not it be a metal? It can part with an electron and become an H plus. Before all these do, copper, silver, gold, all these become ions. That is why hydrogen is called a place in between. And then with the periodic classification, hydrogen has been placed along with the alkali metals. Right on top, along with the alkali metals. The position of hydrogen in the periodic table had raised a lot of controversy earlier, but now it has been placed for the time being along with the alkali metals in the periodic table. But mind you, you must know one thing. It is electropositive. Hydrogen is electropositive. And hence can be included along with the metals. Along with the metals. Now, look into this aspect. Ions will show a lesser tendency than hydrogen ion to get reduced. All these potassium to lead, they are ions which have lesser tendency than hydrogen to get reduced. That means hydrogen has a greater tendency to get reduced than these. These have no tendency to get reduced, which understands it. potassium, barium, etc., they refuse to get reduced because they are themselves reducing agents. These are themselves reducing agents. Any time potassium is willing to change into K plus and give an electron, they are reducing agents and they will not get reduced so easily. They will get oxidized, but they will not get reduced easily. So none of these get reduced easily. And hydrogen also gets reduced, get but hydrogen can get reduced much easier than copper, mercury, silver. That's why it has been placed in this. Now these ions show lesser tendency than hydrogen to get reduced. Lesser tendency than hydrogen to get reduced. Or greater tendency than hydrogen to get oxidized. Lesser tendency to get reduced. Greater tendency to get oxidized. And here I given copper to platinum. These show higher tendency than hydrogen to get reduced. These show higher tendency. These will get reduced faster than hydrogen. These show higher tendency. You must have noticed one thing. This series is got practical importance. We often find. Now, suppose you want a solid solution of one of these. Say a copper salt solution. I would have asked you to name a copper salt solution, but today is not possible. Next day I will make it possible to ask you questions also. Okay. Say a copper salt solution. Here was copper sulfate, copper nitrate, alright? Copper sulfate, copper nitrate, copper acetate. These are all soluble copper salt solutions. In that, you put a piece of iron. A piece of iron you put in that. In a copper salt solution, you put iron. Leave it for some time. What will happen? What will happen? The iron piece, with an iron piece, it will be coated with copper. In a copper salt solution, you put a piece of iron, an iron nail. Keep it for half an hour. You find the nail, iron nail will get coated with copper. That means copper comes out of this and sticks to iron. Copper comes out of this. How can it come out of it? By getting reduced. Copper 2 plus has to change into copper Cu. If this is to change into Cu, 2 electrons are to be added. See? Those electrons are supplied by this one. We need to change any line into Fe2 plus. And this willing to change into Fe2 plus any time. Here is an opportunity. This wants 2 electrons, this gives 2 electrons. So iron, and put in copper sulfate solution. Copper is thrown out of the solution, it sticks to iron. This is with all these things. All these metals, for example, this can displace hydrogen from acids. They are all more electropositive than hydrogen. So they can all displace hydrogen from acids. When the time comes to lead, etc., it's difficult, but most of them can. More electropositive than hydrogen, so it can displace from acids. These can even displace hydrogen from water. The compounds, potassium, sodium, calcium, they can displace hydrogen even from water. Or others can displace hydrogen from acids. So this series is much more relevant than what we just think about it. It tells us many things. Number one, what it tells us is the lesser tendency than hydrogen ion to get reduced. Hydrogen ion has greater tendency to get reduced, and these have got still greater tendency to get reduced. So tendency to gain electron, because getting reduced is the same as tendency to gain electron. You can say reduction is electron gain. Reduction is electron gain. So these elements the tendency to gain electron, that is also from top to bottom. Top to bottom. This has greatest tendency to gain electrons. Platinum, gold, silver, mercury, copper. These have the greatest tendency to get reduced. Greater tendency than hydrogen to get reduced. So, this much if you have understood, you already know much about electrochemical series of metals. This will come handy. This will come handy when we study discharge, ease of discharge at cathode. We have been doing electrolysis all these days. You know, in a solution, if you put two electrodes connected to a source of current, if that solution contains ions, ions will move to the opposite electrodes. They will move to the opposite electrodes, right? Cations will move to, very easy, cations will move to cathode, anions will move to anode. Cations will move to cathode, anions will move to anode. And cathode is the one which is connected to the negative of the battery. Cathode has a lot of electrons in it, connected to the negative of the battery. Anode is connected to the positive of the battery. It is willing to receive electrons. That is it. So, when you do electrolysis, this becomes very handy. We know whether these are willing to get reduced or not. Number one. So, in electrolysis, you will find it very interesting, important. Another thing you should know about electrochemical series of metals is another thing is a metal with a higher position in the series displaces the one with a lower position. Higher position in the series displaces the one in a lower position from its salt solution. From the salt solution of these, the metal will come out efficient DC. These can displace metals from the salt solutions. The one at higher ones. A metal, write down, a metal with a higher position in the series, please write down. A metal with a higher position in the series displaces the one with a lower position. The one with the lower position. Second, metals below hydrogen. Metals below hydrogen cannot displace hydrogen from atoms, while metals above hydrogen can displace hydrogen from atoms. Metals below hydrogen cannot displace hydrogen from acids, while metals above hydrogen can easily displace hydrogen from them. There again, the ability to displace hydrogen varies. Top potassium can displace it in no time. When it comes to that, it becomes very cannot be possible to displace. From here, the activity comes down. That's the second point. Third is electrons. Electrons lower in the series get discharged more easily. Elements more lower in the series get discharged faster than elements above it. In fact, elements like potassium, barium, calcium, sodium, magnesium, these can never be got discharged from a solution by causing electricity. Because they are such reducing agents that they refuse to come out from solutions. That's the next point. Please note down, elements lower in the series get discharged more easily at the cathode during electrolysis because their cations can easily gain electrons. You get it or no? The cation can gain electrons more easily. That's the reason. And so too one thing more. These which are willing to bond with an electron easily will be the last to accept an electron. That also. The ones which will bond with electrons easily are good reducing agents. You see? They are good reducing agents, but poor oxidizing agents. They will not accept electron easily back. They won't accept electrons easily. Now these are the points you should know about the electrochemical series. I hope you understood the topic. I hope you understood. If you want, I can recapitulate it and tell you. Based on the, if you want, you can note down this. Based on the ease with which atoms of metals lose electrons to form positively charged ions. Positively charged ions. Metals are arranged in a series. Known as the electrochemical series. Metals are arranged in a series known as the electrochemical series. Now this is what? Now this is all about positive ions. Metals form positive ions. What about others? There are negative ions also. You already learned, for example, OH is a negative ion. OH is a negative ion. Similarly, iodine is a negative ion. Bromide is a negative ion. Chloride is a negative ion. Nitrate is a negative ion. NO3. Similarly, sulfate, SO4, is also a negative ion. 2 minus. These are all negative ions. First is hydroxide, OH, iodide, bromide, chloride, nitrate, and sulfate. These are all negative. I am not taking other negative ions in consideration now. We are more interested in this because these are the ones which are likely to come up in our course of study. So I am taking these are negative ions. These have also got a series, an electrochemical series. These are also having an electrochemical series. I have written them fortunately in this proper order. This one will part with this electron at the earliest. Next to part with the electron will be this. Next will be bromide. Next will be chloride, nitrate, and last one. Hydroxyl ion, iodide ion, bromide ion, chloride ion, nitrate ion, and sulfate ion. That is the order in which these will be discharged from a solution also. If there is an OH ion in the solution, that will be the first to get discharged during electrolysis. Then may come the iodide ion, bromide ion, chloride ion. Next, the nitrate ion. And last, sulfate ion. Sulfate ion will not easily get separated from the solution. That is the electrochemical series for negative ions. Electrochemical series for negative ions, or we call it by the name anions. Electrochemical series for anions. As far as series are concerned, these are the 2 things you should learn. There are many more things which are present now, doesn't come under your domain. These are definitely very useful because our next topic we are going to discuss is which ion will come out of a solution during electrolysis, provided there are 2-3 of them. Suppose there are two of these in a solution. Suppose two of them are there, calcium and iron. Now you know which one will come out of the solution first. Which one will come out of the solution first? Or supposing there is one ion here, nickel ion, and another silver ion. Which one will come out? It depends upon the position in the electrochemical series. The last one will come out first. Now you know it, Raichur. The last ones will come out first. These will come with some beginning. These will not come whatever you do. Right? Because they are electropositive. They will not come. And here, hydroxide radical will come out first. Then this iodide, bromide, chloride, then nitrate will finally settle. Now, supposing there are two of these in the solution. One is OH hydroxide and the other is nitrate. During electrolysis, which comes out and goes to the anode, OH. This will go to the anode first. Right? If it goes to the anode, normally what happens is it will combine with another OH, one more OH, become two OH, and two OH will become H2O plus oxygen, and OLO will become O2. So, what comes out of this electrode anode will be oxygen. You can judge it straight. Oxygen will come out of the anode first. There may be along with the nitrate also, but nitrate will not come out. It is willing to come out first. So, if there are sometimes what happens, there will be say copper ion, Cu2 plus, and also hydrogen ion, H plus. Both are in solution. Cu2 plus and hydrogen ion both are in solution. They will compete. Both will go to the cathode. They are positive ions. Both will go to the cathode, compete with the cathode. Who wins? Who will win? Copper ion is there, hydrogen ion is there. Who is going to win? The one ahead of copper, hydrogen will win. See? So this way, you can easily understand which ion comes out of the solution. That will be the next class, and the next class is on the selective discharge of ions. And nobody told me that this is quite clear to you. Only if this is clear to you, I will go to selective discharge of ions. Just to see whether you have understood it well, I will ask you one or two small questions. There is chloride ion and hydroxide ion. Chloride ion and hydroxide ion. Two anions. Chloride ion and hydroxide ion. In selective discharge of ion, what will come out first? I don't hear you. If you all answer, probably I would have heard it. If this is present, the one coming out will be hydroxide ion. And hydroxide ion combines with another hydroxide ion, forms two OH, that is H2O plus O, OH combining, oxygen comes out. So this way, if you know this one thoroughly, then we can go to selective discharge of ions. If you know this thoroughly, we go to selective discharge of ions. Okay. I think that you have a command over this. I have it out. Okay. Softly. And the class also will be ending just now. Next class, we'll take it up when I will try to see whether you can also be included in my questions and answers. Thank you. Take care. Bye.